Hi everybody. Today we're going to talk about the water resources in North Carolina. So we're going to progress. We have a first seed question here. What does water balance mean? So when you look at this diagram right here, and let me get my pen going here, you can view this particular item right here coming down would be precipitation right here. And then this arrow that's flowing upward would be evaporation. And it's where the two items right here actually equal each other. So you get the same amount of precipitation that comes down will balance out and equal the same amount of water that's being evaporated up into our clouds or atmosphere. So that's what a water balance means. When I look at the next one, a water cycle. Now, since second grade, water cycle has been out there. It's basically showing all the different components in a water cycle. This one is a diagram that demonstrates it. And I also have a link here to the water cycle and also tracking raindrops video that's available as well. So let's look at the parts of the water cycle. So the first one is evaporation. And that one is where the water will change into a vapor and go immediately into the atmosphere. Then we have precipitation. That's where water, it can be in a liquid form such as water, or it could be solid form where it's actually hail that's coming down. You have infiltration. That's where water is moving through the ground, penetrating and actually entering our groundwater reservoirs that are down there, our wells that are in there, aquifers. Then we have transpiration, and that's kind of unique, and it's a small amount, but it's where water is released from the plants back into the atmosphere. And then we have runoff, is where when you get a flash rain, a storm, and it hits the ground, and it's coming in so much that it actually will run off on the ground into our streams, creeks, and rivers. And with that, it could deposit or take with it some of the soil and things like that that can create some environmental hazards with the amount of soil that's in our water, meaning a turbidity problem. Some other water facts, we've got several listed here. I think some of the ones that's kind of unique is that 75% of the human brain is water, and 75% of living tree is actually water as well. A person can live about a month without food, but we need water in order to survive. We cannot make it no more than maybe a week at that. And then the average total home uses 50 gallons a day. So you had an activity where you're seeing how much water you consumed. So I think that's kind of unique. And then the last fact down here, 9%, water expands about 9% when it freezes. So on that one, the water or the air molecules that are within the water are trying to push themselves outward, thus creating the surrounding area of the ice itself. It kind of expands because of the air trying to push its way out, but the outer regions of it freezes first. So let's look at the water supply of the earth. So we know that 71% of the earth is made up of water. Of that, 97% of the water is found in our oceans, and then the remaining 3% is fresh water. So then you can see that the biggest bulk of fresh water is found in ice and in glaciers, and then the rest is found in our aquifers or our groundwater supply, and then the smallest amount is in our rivers, creeks, streams, lakes, and also even within the atmosphere. This is another great graph that shows the distribution of our water supply from the oceans with higher salinity levels all the way down to our freshwater supplies. This is very interesting. Our water is used in various ways. The number one way that it's being consumed is actually through irrigation. 70% of it's used for farming, for irrigation. 20% is actually used in industry. And think about ECU, those cooling towers that are right behind Flanagan. You can hear it working, and it's trying to cool down some of the machinery and systems in there. And then also 10% is used in our cities and residents. That's personal use as well. Some other facts about freshwater supply. As I said, the biggest use of fresh water is actually used for agriculture. And the typical person in an industrialized nation, not in a third world country, uses between 700 to 1,000 gallons per week. And now that we're home with Corona, the COVID-19, we're probably using more water than typically if we were out and about. So let's look at our groundwater supply. 50% of the water is used by the public or most of our water supply, like in the Pitt County. About half of Pitt County uses groundwater. I live on the outskirts of Pitt County, even though I'm right within the city limits, but I get my water from, what's the name of the place, Bill? Eastern Pines. Eastern Pines Water is where we get our water. It's an aquifer close by. But if you live within the city limits, like right downtown in Greenville, all of ECU, they get their water supply from actually from the Tar River. Okay. So, and I also have a link here to groundwater, understanding it. Now, for our water, our groundwater is naturally filtered, and so it's really clean, pristine through the particles and things that are pulling out pollutants that are in there. Although there's certain things when we look at the water quality that quite are not being pulled out. But one of the ways that the water will move through it is through porosity and permeability. So porosity is that percentage of pore space that shows how much water is actually being stored within the rock. So you can see where you have sand particles, you're going to store more. It has larger pore space in between particle to particle, and more water is actually going to be stored in there. So its porosity rates are higher. Permeability is the ability for water to pass through in those connecting spaces. So when we look down here at this graph down below, you can see that if I load a bunch of gravel in this particular area, it's going to run through real quick. Within 2 minutes, you're going to get water to pass through that 1 meter level of gravel. It's going to run fast versus sand, which is from the sand, silt, and clay. Sand is the largest particle of those three, 2 hours for it to pass through. And then look at this with the clay. This is phenomenal. 200 years for water to actually pass through, depending on the level up there. So that's probably about, looks like, in comparison to the 1 meter, maybe a fourth of a meter. That's very interesting because growing up on a farm, we used to have ponds. And one of the natural ways to have a pond layered before you start it is actually using and making sure that it is clay lined in there. And it will eventually through the years dry up, or it will infiltrate and get into the ground. But one natural way is using clay. Again, the movement of water passing through the soil types. With clay having the smallest pore space, it is not a very good permeable space, but it will allow to hold the water intact above the surface. The silt is a medium one. Of course, sand has the largest pore space, so therefore it's very permeable. If you have your plants on a sandy soil, water's just going to run through it, so it's not going to be able to hold the moisture and the water in there, so your plants will probably dry out. So you need some good mix between the clay and the sand and the silt all mixed together to make it to where it locks in and the plant is able to get a lot of water or nutrients there, and that mixture is called a loam. They are by far the best. Now, if you go to Lowe's and you buy your potting soil and things like that, they add other components in there like vermiculite and some other components in there that actually will lock in and hold moisture in there. It's a not natural particle in there that kind of locks it in. When we look at our groundwater, there are different levels. Like on the top of the ground, we come down until where we hit it, where water, we're spiking and we're hitting water. That is called the zone of aeration. And think of the word air in their aeration, where this is more particles where air is in there, the water has already infiltrated through on there. Now your water table is actually the top layer. It's sort of like the ocean. It would be I'm trying to think, sea level. Like it's the top where the sea level is, where the top portion of an ocean is touching the actual land right there. That is sea level. So a water table would be the highest part where that water is located within this region. And sometimes you hear about our water table dropping. It's because the water sinking down or being pulled out or withdrawn in that particular area. So the zone of saturation is where all the water is trapped into the soil down below or into the rock layer. Okay. Groundwater, again, how our water is stored. They're stored naturally in things called aquifers. And basically down below, like right in here is all this water. But down below you probably have impermeable rock. Impermeable means it can't penetrate, can't pass through. So you have this water that's being stored on top of it. So, but the water is passing through the permeable surfaces such as gravel, sand, or silt and being held there. Well, sometimes for personal use we use wells. PCS phosphate, which is now Nutrien, is withdrawing a lot of the water down there in that Castlehane aquifer, and it's being pulled down. And so therefore you can see as it's being pulled down, we're getting a V-shaped right here. That's called a Kona depression. And sometimes it can lead to that where we're withdrawing so much water that we're having to dig deeper in order to pull out the water. Now, luckily with the Castlehane aquifer, it is able to recharge at a faster rate. And as you move more west in the state, the levels or the times it takes to actually recharge a well takes a lot longer, maybe hundreds of years, whereas in the Castlehane aquifer down there at Potash or Nutrien now, it will take weeks or months actually to recharge those wells. So even though it is an environmental concern, it can recharge at a faster rate rather than heading down the road in there. So again, the artesian wells are just these aquifers that are down beneath the soil down in there. These are naturally occurring aquifers. And one thing I do want to say about an artesian well, they are very pristine water. I grew up on a farm where we used well water for years until withdrawing the water for farm use, and it dropped our water table. Eventually we did move to the buying water from North Lenoir Water Corporation in Lenoir County. But one of the things, my father did have heart attacks, and one of the things they were concerned about, and we had to give them water samples because we were on well water, they found that there were higher levels of sodium in the water. So sometimes you run that risk in there. So pumping out the water can cause our water table to be lowered, and that is a concern. And sometimes these artesian wells just don't recharge it, because of Larned County it takes a lot longer for it to be recharged.